Introduction. Every day as Jakartans, we travel to work or study by vehicles, whether it's a motorcycle or a car. With how packed Jakarta is, from time to time, finding parking lots in high-rises or apartments could get more difficult. So we thought that the solution would be, in our project we will make a IoT device which attempts to address the problem of the lack of parking space and parking convenience by applying smart payment systems, a license plate recognition device, and an automatic gate lift. Some changes to our initial plan include scrapping a collision prevention device because of insufficient resources, and we decided to put a servo to allow ease of recognition that the license plate has been scanned. For the next part, it will be the demonstration, and from here, Alice would demonstrate how the device works.
Okay, so here is our code for our project. So I created a little bit of files here. So the most important file that we might need is the DB function. So in our database functions, we have like the connect to database. So we have it returns a function that returns the database object. So you have to input your server name. For ours, it's on Amazon, so we have to put in a string here for our host Amazon. User password, then your database name. Then after that, we also have DB functions. So here are most of the functions that actually require database operations. So we have insert, which needs the plate number, stamp, and designation from our table. So this one is actually used for the first time you enter into the parking lot. So in the residence. So the time you enter, you get your number plate. We put it in the in the database. Also, the stamp is like timestamp, and the designation defines if you are a resident or not. Then we also have a check for number plate. So here we're just checking if you are in the database, so that we can define if you're a resident or you're just a visitor. Then we can update some of the counters. So we have some counters table where we can count the number of parking lots that are available, the number of parking lots that are used up, and who are in the parking lot. Are they visitors? Are they residents? Are there more visitors than residents? etc. So these are the functions that are usually used for the dashboard. Then we can update also the counters. When you get in, we have to update the counters. We're subtracting one or we're adding one, depending on is it an entrance or is it an exit. Then we go to our OCR. This is one. So here in our OCR, we are getting an image from the camera. So we capture an image from the camera. Then we send the path of the image to this OCR function. This OCR function will go to API, OpenAPLR API, to get the string of the pass, the number plate. Then it returns the string here that will be used for our database or something like that. So then we have servo. This one is basically just for our gates, so that we set up our angles for our servo motors, so that we can open and close. So MainPy. In MainPy, basically what we're doing now is the operations. So it's not really a huge file, but we just import all modules from the connecting, the OCR, the save, or etc. So what we just need to do is define our pins. So we are setting our infrared sensors, IR sensors, the one for in pin 16, out pin 37. Also do our LEDs. These ones are green. These ones are for the entrance, the exit. Then we also have some patterns that we're also using. We are also using. Then here, what you do now is you set up now. So you declare the pins here, you set them up. So you are defining if this pin that you've just set here is used for output or input. So here would say the LED is all for output, but the IR sensor, because we need the signal from the IR sensor, so it's input. Then also the buttons are input. Then we also set some conditions. Then we loop a while loop so that it's continuously running all the time. Then we set some state for input. We assign it to the input from the IR sensor. So let's say the input now goes to false. That means we have an object that is on what is in front of the sensor. So it will print object detected on in. We get the timestamp. We get the image from the camera. We get the number plate from the OCR. We print the number plate. Then we get the designation from checking from the database. Then after that, after we get the designation here, we'll check if it's a resident. Then we'll just insert that one and name it as resident. Then we update all other tables. We open the gate here. Then we wait for about a few minutes. Here it's 5 seconds. You can increase the time. Then we close the gate. Then we let the red light on and we switch off the green light. Otherwise, so this one is for resident. So if you're not a resident, then you need to press a button so that it knows that you're a visitor, because your number plate was not found in the database. The same thing happens also if nothing is detected, it will just sleep and continue to light on the red light. But for the same thing also will happen when you are on the outside, when you are coming outside. So here is state for outside. So when it's false, then we will set the time to sleep 1. Then we print object detected out. Now we get the image from the camera again. We get the number plate from the API. So now that the number plate is here, now we just go and get the index from the parking table using that number plate. Then what we get now just 2 variables: the designation, the proceed or no proceed, which is check, which we use function called check exit. So it will return whether if you are already in the parking database and your status is in. If a string go is returned from the proceed, then we just update the table. Now we set the green light LED to true. Then we open the gate, we update all tables, setting the number of cars inside +1 or -1, depending on what's happening. And then we close the gate, or else we will check. So if a car comes in and something happens and you're going out and your record is not found, then we have an error. So there will be need for some kind of manual. But then this system is kind of made to be fully automated. So there's going to be need for doing the errors. So now I'll leave the time to a demonstration of how it actually works.
Parking model. So as you can see from here, we have our dashboard. So we have 50 free slots, and we don't have any residents or visitors. And from the Raspberry Pi, the code is actually running now. So let's try to see. So this one will be our model car. So we have an IR sensor here, a cell phone. It's up to LEDs, red, stop, green, go. So we'll try to see here. You can also check on the console. You can see that the gate is open, and in about 5 seconds the gate will close. Then we can now refresh our dashboard to check if it's so now you can see that there are now 49 free spaces once used, and it's a resident. Then the same thing we can now do is try to get out. So we come from this side. And because we just use only one camera, so this side doesn't have a camera, so we can have this one. Then to get to open. And very soon to close. We can do the same again and check our dashboard. We can just refresh our dashboard again. Very good. And you can see down 50 and 0 species, no distance. Now you can also see here it opened the gate, closed the gate, and updated some records. So that's it. Maybe you can see the wiring, the complicated wiring stuff, and some errors.